Okay, so this is Prep Test 60 Game 2, and it's an ordering game. We have exactly 6 actors, G, H, J, L, M, and P, appear one after the other in an opening credits of a television program, and we have to figure out the order of their television credit thingy. So I have 6 of them. 1, 2, 3, 4, 5, 6. Okay, so I'm going to go into the first rule, which says both L and M appear earlier than H. So first rule, we have L and M as appearing earlier than H. Cool. Rule number 2 says L and P appear earlier than J. L, P, earlier than J. Cool. So I can actually combine these 2 rules to make it a little bit easier on us. Oh, I don't know what that was. So I can actually combine my L's together. So I'm going to take, the way that I do that is I take one of the sets and I just attach the other one onto it. So something like this. Cool, so now I don't have to worry about these anymore. I'm just sticking with this one for right now. Second rule says if M appears earlier than P, then H appears earlier than G. Okay, so I either have M appearing earlier than P, or I have P appearing earlier than M. It's going to be one or the other because they have to go in some sequence, and this is only restricting me to when M appears earlier than P. So I'm actually going to make a copy. Sorry, this is really bad. We're going to make a copy P, L, M, J, H. Okay, so we're going to have one in which P is before M and one in which M is before P. And the way that I'm going to do this, because it's already in my diagram, is I'm going to give myself some more room to begin with. I'm actually going to stretch this out and connect it to the other variable. So right now, they're all linear. And to me, that means that not one, like it doesn't matter what order they're in, they're no higher than the other. So at this point right here, M could be earlier than P, L could be earlier than M. Doesn't really matter what order because they're all linear. So for me, what I'm gonna do is I'm gonna take M and I'm gonna stretch it out over here. So M is still before H, but now to me, it's telling me for myself, M is before P. So I've stretched it out to where M is actually happening before P, like visually happening before P. And I can actually also stretch L out here because M also does not have to go before L. It doesn't really matter. L also has to be before J though. So I've created this weird web basically. To me, this makes sense. To others, maybe not so much. Basically what I'm doing is I'm pulling and I'm stretching so I can at least see like maybe a little bit visually what's happening here. So going back to the rule, when M is before P, I'm following my arrow, it's before P, then H is earlier than G. Okay, it's a weird world, but we'll revisit it and it'll make a little bit more sense because we're going to start putting numbers next to it. Okay, come on. Can I please move you up? Okay, cool. So then down here, I'm going to make it where P is actually earlier than M. So we're actually going to stretch P out before M, attaching it back to my J because it has to be before J. Now P is earlier than M. When P is earlier than M, we don't know what happens, so we don't really care. And again, you can also stretch L out to meet P like we did up there. And I can actually do that right now. It's gonna look a little weird. Kind of like a fish. Cool. So we're gonna make this a little bit more clear, and it'll hopefully help a little bit. So we're gonna go back up to 1. Now when I have a mapping diagram kind of like this, I always ask myself what can be first and what can be last. And so going into this first world, which variables could be my first variable? Well, because I've pulled those variables out, I know that L and M could be my first variables. The other variables that follow after that have something before it, so it can't be the first variable. So I know L and M have to be my first variable. Now I ask myself, okay, well, if L can be the first variable, then what's the latest that it could go? Could it go 4? Could it go 5? What's the latest? And the way that we find this out is we figure out what it's connected to. So we follow our line. So L is connected to J. L is also connected to H, which is then connected to G. We go from left to right. So we can't backtrack and go, okay, L is connected to H, which is connected to M. We're going to go straight through because we're following our chain. So because we know that L is connected to J and connected to H and connected to G, we know that 3 spots have to be saved. The furthest that we can put L is 3, basically, because we have to have 3 spots for our variables that come after it. So therefore, we know that L can be 1, or it could go 2, or it could go 3. We're going to do the same thing here. We're going to follow our lines, and we're going to ask ourselves how many spots have to be saved after M, what follows after M. So we have M comes before P, which comes before J, and then M comes before H, which comes before G. So I have to have 4 spots saved for M, or for variables after M, basically. So I count backwards, 1, 2, 3, 4. So this spot. So it can be 2. M in this world can either be 1 or 2. Cool. So then I have figured out which ones could be my first variable. Now I'm going to ask myself which ones could be my last variables. Well, the only variables that don't have anything after it are J and G. But because of our last rule, G does not appear last, we can't have G be last. So that tells me that J has to be 6. It also tells me that G, the latest that G can go is 5, because we can't have it be 6 and there's nothing else after it. Now we're going to see how early our variables can go. So we're going to do what we kind of did earlier. We're going to follow our lines and see which variables have to be before J. So we know P has to be before J, which has to be after M. So M and P have to be before J. And then L is also connected to J. So we have 3 spots. So 3 spots have to be before J. So the earliest that J could go is number 4. We're going to do the same thing again with G. We're going to count how many have to be before it. So H has to be before it, L has to be before it, and M has to be before it. So 3 spots before G, which means 4. So those are really the only variables that I care about, the first and the last ones. And from there, you can kind of see what's the most restricted variable. I'm looking at M and G because they can only go in one of 2 places. And that's where you can start to make your worlds. So I could start, let's just start with G. We know G could be 4 or 5. And then we know that M could be 1. Maybe I should move this. M can be 1 or 2. Oops. M can be 1 or 2, and then when G is 5, we know that M can be 1 or M can be 2. And then you can kind of fill out your diagram from there, following your variables. So we know that M has to be before H, which has to be before G. So in this world, it forces H to go there. In this one, it means H is going to flip-flop here, and H is going to flip-flop here. H is between here. But L also has to be before H. So that means in this world, L is going to go here. H could go again in 3 and 4. You see what I'm doing kind of, so like up here, we know that L has to be before H here, which then means P and J. That's a full world. I guess we could just fill J out here. Basically, we know J has to be last. So then P would go here. And then we know L has to be before H, and P doesn't really matter. It's kind of a floater. So in here, L has to be before H, and P's our floater. In this world, L has to be before H, so L can only go in one of 2 spots, and we fill in our worlds here. So that's a fairly easy world to kind of go off of, but that's just number 1. So we're going to go into our second world, and we're going to do the same thing. We're going to count which ones can be our first variable and which ones can be our 6th variable. So we're going to start with our first variable. We can have 2 variables that could be the first one because there's nothing that's coming before it. So we can have L as our first variable or P as our first variable. Then we're going to count how many variables have to come after that one. So with L, we're going to follow our line. L has to be before J. L has to be before H. Sorry, my things are kind of not very blatant. Okay, we're just going to leave it. I know what I'm doing. L has to be before J, and P has to also be before J. Okay, cool. So L has to be before 1, 2, 3, 4, 5. We're missing our G. That's a 6. So this is our floater, which is kind of scary because it can pretty much go anywhere. We can actually figure this one out fairly quickly just based off our last rule. Because it can't be 6 and it's our floater, that means that G can actually go 1 through 5, which is a lot of different spaces. So that's our floater, obviously. L now, that only has a few spots that it can go. So we have to have J after it and we have to have H after it, which means we have to have 2 spots saved for L after L, which means saving 2 spots, L can only go 4th, or latest it can go is 4th. So we're going to do the same thing with P. We know P has to be before M, which has to be before H. And we know that also P has to be before J. So we've counted 3 spots that have to be saved for after P, which means P, the latest that it can go is number 3. Cool. So now we're going to figure out what can go last. And we figured that out by what variables don't have anything after it. So I have J and I have H. And then obviously if I had another floater that could also be counted, but because G can't be last, we don't have to count that one. So J and H can be last. So then we're going to count backwards. We're going to see how many spaces have to be before J. So we have to have P before J, and we have to have L before J. So only 2 spaces before J, which means that the earliest J can go is 3. We're going to do that again with H. So with H, L has to be before H, M has to be before H, and P has to be before M. So 3 spaces have to go before H, which means that the earliest that it can go is 4. So those are our numbers, which unfortunately doesn't really give us a whole lot of restrictions. Unlike World 1 where I had G and M only having 2 spots, this has a little bit more flexibility. So picking the most restricted variable, I would say that's either going to be J, P, or H. Really doesn't matter which one. Either way, it's not going to be pretty. We're going to have a lot of worlds. That's why I usually say if this is enough for you, which can be enough to answer some of the questions, or at least to diagram some of the questions. If you get to questions you need a diagram, then keep this. But if you need to visually put it, like write it out, then write it out. So I'll just do a couple of them. So we'll pick P to start off with. So we know P can go in 1, P can go in 2, and let's drop that a little bit lower. P can go in 3. So when P is in 3, we know that we have to have J and M and H after it, M being before H. So M can only go in a few places. Up here, it doesn't really matter. J would have to go here. And then you have, what do we have? L, G, oh yeah, those are only 2 spots, sorry. L before G, so, well, L doesn't have to go before G. Following my wrong line. And then when P is 2, we're basically going to repeat it. So where could M go? Because we know M has to be before H. M could go in 3 through 5. You can write that out, then figure out where your H goes, then pick another variable and see where then that goes, because that's probably going to force some of our other variables to go in order. But that's basically the gist of it. So I would really practice something like this. This is going to help you kind of go quickly through the questions, especially on these types of games. You're going to get questions that are like, how many of the variables could be last? Which ones could be last? Which ones could be first? How many can be first? And so writing down your numbers can be really helpful. And then if you get to an if question where it says something along the lines of, if P is number 1, then what could happen? You can just kind of count your variables and go from there. So could it happen that G is number 4? It could happen because I know G is a floater. Could it happen that H is 3? Nope, because it can't be a number 3. We only know that it can be 1 or 4 through 6. So that can be kind of helpful too. So hopefully this helps a little bit. If not, please let me know. But yeah.